Today we will be going over certain new mechanisms in cloud infrastructure and also revisiting a few things we talked about earlier, like horizontal and vertical scaling and also load balancing. These concepts are all connected, and by the end of today's class, you will see how they perform the backbone of self managing resilient cloud systems. So let's start with automating scale listener. You remember from our earlier discussion, we always talked about horizontal scaling. That means adding more servers, and vertical scaling. That means adding more power to one server. This listener builds on top of that. Think of it as an intelligent monitor that's always listening to what's happening inside your system: CPU load, memory usage, network traffic, maybe even the number of active requests. When these signals cross a certain threshold, like CPU usage hitting 80%, it triggers an automatic scaling policy. That might mean launching a new EC2 instance, spinning up another container, or when traffic drops, scales down to save cost. So the listener listens to real time performance data and responds instantly. That's what gives the cloud its elasticity. Load balancer. During our live sessions, we talked about load balancing in so many different demos. So remember how we distributed traffic between multiple backend servers? Load balancer is that traffic cop standing in the front door of your infrastructure. It receives all of the incoming requests and decides which server should handle each one. This prevents one server from getting overloaded while others sit idle. It also improves fault tolerance. If one node crashes, the load balancer automatically reroutes traffic to the healthier one. It can follow different strategies like round robin, sends requests in order to each and every server. These connections pick the server doing the least work. An IP hash wouldn't make much sense because users would still be hitting the same machine. Next up is the usage monitor, essentially the cloud's activity tracker. Once your scaling and balancing are in place, the system measured how your resources are being used. The common metrics include CPU and memory utilization, disk read write speed, network bandwidth in and out, API call counts and latency, storage space per service or user. These numbers are useful for both engineers to detect performance issues or for finance teams since they tie directly into billing. It's the same idea as checking your phone battery stats, only here it's your virtual machines. Speaking of billing, that brings us to pay per use monitor. This system turns all those raw usage metrics into actual dollar amounts. It's what makes the cloud business model work. You pay for compute, storage, or bandwidth only when you use them. For instance, AWS or Azure will measure your instance uptime, API requests, and gigabytes stored, then multiply that by the current pricing rate. This is the utility side of computing. Let's shift to something more serious: security and accountability. The audit monitor is like CCTV system of your cloud. It records every important event: who logged in, what configuration was changed, and what API calls were made. These logs are critical to compliance. Frameworks like HIPAA, SOC2, and ISO all require them. If something strange happens, say IAM permission is changed at 2 a.m., you can go back to the audit logs to find out exactly who did it and from where. It's what allows administrators to trust complex multi user systems. Even with all that, failures can still happen. Maybe a power outage or even an entire data center region goes offline. That's where a failover system saves the day. It's designed to detect failures automatically and switch operations to a backup server or site without human intervention. There are two main patterns: active passive, where the backup waits in standby, and active active, where both sides are live and share the load. AWS Route 53, for example, can detect when an endpoint becomes unresponsive and instantly redirect users to a healthy region. The idea is simple: users should never notice that something broke. Now let's talk about resource clusters, the real muscle behind large scale computing. You might have heard about Hadoop, One of the earliest systems to make use of clustering, Hadoop splits massive data centers into smaller chunks, sends each piece to a different node for processing, and then combines the result, like dividing group project among many students. That's exactly what a cluster is, a collection of interconnected servers working as one logical unit. Modern tools like Kubernetes or Apache Spark take the concept even further, managing load distribution, scaling, and health automatically. Clustering gives us speed, redundancy, and efficiency, the three pillars of modern computing. Alright, now let's move to something that connects all kinds of devices, the multi device broker. In today's world, your cloud isn't just talking to web apps, it's talking to phones, sensors, smart TVs, and industrial robots. The broker is like a translator or post office that takes data from devices using different languages, say MQTT, HTTP, or COAP, and ensures everything can communicate smoothly with the cloud. It also handles authentication and guarantees message delivery even when the data device loses connection temporarily. Azure IoT Hub or an MQTT broker are great examples. They make it possible for your Raspberry Pi project and a smartphone app to coexist in the same ecosystem. Finally, let's talk about state management databases, one of the most quietly critical parts of the cloud. Web servers are stateless by design. They don't remember anything between the requests, but users expect continuity, staying logged in, keeping shopping carts, remembering preferences. A state management database such as AWS DynamoDB solves that. It stores session tokens, temporary user data, and cache information that must persist across servers. Just last week, AWS had a regional incident involving DynamoDB, where some services experienced slowdown due to dependency issues. When state storage hiccups, everything from authentication to dashboards can lag. The databases keeps user experience seamless no matter how many servers or regions are involved. So if we step back, the automated scaling listener expands capacity, the load balancer spreads the network, the monitors keep an eye on performance and cost. The audit systems ensures transparency, failover keeps uptime high, clusters provide parallel power, brokers connect every kind of device, and state databases hold it all together. And that is all for today. See you again in the next class.